Today's lesson is section 6.3, and it's using elimination to solve a system of equations by using addition or subtraction, because actually 6.3 and 6.4 are both using the elimination method. It's just today we're only going to use addition and subtraction. So first of all, let's figure out what the elimination process is. So it's the process of adding or subtracting two equations, like the number 2, to eliminate one variable. All right, so I'm going to see if I can write off to the side. There's a couple things we need to remember. I'll write them over here. So I always think same, if the terms are the same, we subtract. Okay, and if they're opposites, we add them together. Right, so this is going to be very similar to like a 3-digit arithmetic problem. So we have our two equations here. It says use elimination to solve the systems of equations. So I'm going to rewrite them. So negative 3x plus 4y is equal to 12. And then 3x minus 6y is equal to 18. So we're going to use the same subtract, opposite, add here in a little bit. But the first thing we need to do is make sure both equations are in the same form. Typically, we have them both in standard form. So I'm just going to write for our step 1, equations in standard form. Because if they're always in standard form, if you remember ax plus by equals c, then all of our terms will line up together. So notice how our x's are in the same column. Then notice how our y's are in the same column. And then finally, we have our constant terms both on the right side. So that's very important. X's have to be aligned, y's have to be aligned, and constant terms have to be aligned. So with this, let me see if I can erase those now. Okay, so there's our two equations. I'm looking for either the x coefficients or the y coefficients to either be the same or opposites. Okay, so remember the coefficient is the number in front of the variable. So I'm going to start looking at my x's. My x coefficient is -3 and +3. So those are opposites, so that's good. I'm going to look at y's just to see what happens there. My y is a +4 and a -6. -6 and +4 are not the same, and they're also not opposites. So we're not even going to be concerned with the y values. We're just going to go ahead and look at our x values. So if I have -3 and +3, those are opposite numbers, so we are going to add this system of equations. Let me get a different color. We'll do gold. Hopefully that's bright enough. Oh, nope, not quite bright enough. We'll just get a blue. So we are going to add these two equations like it's one great big addition problem. So when I do this, I get -3x plus 3x. That gives me 0x. And if you remember, we don't even have to write that, so that sort of goes away. I have -4y plus, a positive 4y plus a -6y. So 4 minus 6, that gives us a -2y. And then I have to, again, add my 12 plus my 18. And that will give me 30. Excuse me. So now I have to, if you notice, I'm going to erase this to make it look a little bit neater. My x values completely went away. So now I have an equation that just has one variable in it, and we can solve that. So to get y by itself, we're going to divide both sides by -2. So we get y is equal to -15. But don't forget, we're not finished because the answer or the solution to a system of equations is an ordered pair. So now we have to find our x value. So you can substitute it into either equation. I'm going to substitute it into, that's our first step, here's our second step. 3x minus 6 times -15 equals 18. So 3x, whoops, that's going to be a plus. 6 times 15 is 90, so plus 90 equals 18. Subtract 90 from both sides, and we get 3x is equal to -72, and divide both sides by 3. We get x is -24. All right, so that's our first example. The other reason we would want to use elimination here is because if you look at both equations, it would be more difficult to solve by substitution because I don't have any variables that are isolated. And I could, but I might have fractions in the way. So that's another reason we want to use elimination. Right, take a moment, pause the video, and then come back and check your answer for your turn. Now, hopefully here, you notice what mistake did I make here. So I first want to go through because I've been looking at some things from the past, and this is what a lot of students do. So they solve for x, and then if you look at my step 2, I accidentally substitute in for y. So most students would get this, and they would just write them as an ordered pair. But please remember, if you have 2 x's, then you need to do something else. So let's go back and substitute this in correctly. So that's my x value, and now I have to solve for y. That looks much better. So don't forget, I think in the last one I forgot to write it as an ordered pair, but there's the solution as an ordered pair. All right, moving right along. Example 2, use elimination to solve this problem. So I'm going to rewrite them. Now my x values are not the same or opposites because one's a 2, one's a 3. I'm sorry, my y values, but my x's, they are the same. And when they are the same, we need to subtract. Now, if you are okay remembering to subtract every time, that is fine. However, if you think you might forget, you can distribute that negative. That way you constantly remember that you're actually subtracting here. So 4 minus 4 is 0, so that goes away. 2y minus 3y is -1y. And 28 minus 18 is 10. So now if I divide everything by -1, we get y is equal to -10. Again, we have to substitute this into either equation. I'm going to use the bottom equation. So 4x plus 3 times -10 equals 18. 4x minus 30 equals 18. And then we're going to get 4x is equal to 48. And then we're going to get that x is equal to 12. So my ordered pair here is 12, negative 10. All right, take a moment. You have 2 your turns to try, and then you're all done for the day. Notice how for this one, I have now changed that y was negative, but since I'm subtracting, 2 negatives make it a positive. So I went ahead and changed that. All right, so hopefully you were able to get both of those answers. For some reason, I was second guessing myself on your turn A, just going through it quickly to make sure I did it right. But I'll check after this, and then if I need to edit the answer, I will just go ahead and add that to the video. So there are your notes.